Unveiling the mystery of contour integration. Hello, everyone. Today, we're diving into an intriguing mathematical concept known as contour integration. This topic might sound complex, but don't worry. We're going to break it down together, making it accessible and understandable for English language learners. So, grab your notebook, and let's unravel the mystery of contour integration. Contour integration is a method used in complex analysis, a branch of mathematics that studies complex numbers and their functions. In simpler terms, it's a way of calculating the integral of complex functions along a certain path or contour in the complex plane. Think of it as tracing a path on a map and calculating the distance traveled. But in this case, we're working with complex functions instead of physical distances. Before we go further, let's understand what the complex plane is. Imagine a flat surface where every point represents a complex number. This plane is divided into two axes. The horizontal axis represents the real part of complex numbers, and the vertical axis represents their imaginary part. It's similar to a traditional graph, but instead of x and y, we have real and imaginary components. Contour integration is not just a mathematical exercise. It has practical applications in various fields like engineering, physics, and electrical theory. It helps in solving complex problems related to waves, currents, and oscillations. By using contour integration, we can simplify these problems and find solutions that are otherwise very difficult to obtain. The process involves choosing a contour or path along which to integrate, defining the complex function, and then applying Cauchy's integral theorem or residue theorem to evaluate the integral. These theorems are powerful tools that allow us to calculate the integrals without having to perform complex calculations directly. To better understand contour integration, let's look at a simple example. Suppose we want to integrate a function along a circle in the complex plane. We would define our circle, contour, express our function in terms of complex variables, and then use the residue theorem to find the integral around that circle. This process highlights the beauty and elegance of contour integration in simplifying complex integrals. And that wraps up our exploration of contour integration. I hope this video has demystified this fascinating concept and shown you how it bridges the gap between abstract mathematics and real-world applications. Whether you're a student, a professional, or just a curious mind, understanding contour integration opens up a new perspective on how we can solve complex problems. Thank you for joining me today, and happy learning!